we are honored to have Yihui to give us a presentation on an anatomy of R Markdown with minimal application. And Yihui, I think most of you know, is a software engineering at Positive Software, PBC, previously the RStudio. And during talk, if you have any question, you can put it in the QA session. It's on the very bottom of the right corner. You can put your question over there, and Yihui will answer your question after the talk. Well, without further ado, let's welcome Yihui. Thank you.
Thanks. Thanks for the invitation, June and Linglong. I'm very honored to give a talk today on R Markdown. This is not a usual talk that I would give. It's quite technical, so hopefully you will not be too bored today. So before I get started, I want to briefly mention that this talk is intended for people who are minimalists and also hackers, and which is like, yeah, I'm both a minimalist and a hacker. So, and oftentimes I strongly believe the definition of being rich, like just like what Seneca said several thousand years ago, it's not the man who has too little that is poor, but the one who hungers after more. So I firmly believe that. So today I will talk about some minimal applications of R Markdown. So, and I will also write a blog post about this talk later. You can check out that blog post in my personal blog. So I think most people in the audience should be familiar with R Markdown. Just to recap, the basic idea of R Markdown is that first we've got a source document, that is the R Markdown document. We will convert that to Markdown output. So, and then we convert Markdown output to a target format, for example, like HTML or LaTeX or Word document. So, so here are two common examples. One is an R Markdown document, usually with the extension RMD. So we first compile R Markdown to Markdown, which has the file extension .md. So this step is done through an R package named knitr. And then we convert the Markdown document to other document formats like HTML or LaTeX or Word document. This step is usually done through a tool called Pandoc. So that's typically how R Markdown works. And also, some of you might heard of Quarto, which can be considered like the next generation of R Markdown. So for Quarto documents, they usually have the extension QMD. So first we compile QMD to MD. This step can be done through either Jupyter or knitr. And then the second step is similar to R Markdown. It's we convert Markdown to other document formats through Pandoc. So today I'm not going to talk about the first step. I'm not going to talk about knitr or Jupyter. I'm only going to talk about the second step today. That is how we convert Markdown to other document formats. And so I would like to show you some the minimal HTML document and also a minimal LaTeX document, in case you're not familiar with HTML or LaTeX. So an HTML document is essentially a plain text document. It has several tags. For example, the whole document starts with the HTML tag, and then this document has some metadata, which is stored in the head section. So you see here's a head tag. So in the head tag, you can insert many other tags like the title tag, which specifies the document title. Most of the elements in the head section, you won't see them on an HTML page because they are mostly metadata. What you see on an HTML page or a web page is actually the document body. That is the visible part of a web page. So as long as you have a web browser, you can right-click on any web page in your web browser, and there should be a menu named View Page Source or View Source. So if you click View Page Source, you will see the HTML, the full HTML source of a document. You can see there are a lot of tags. And as I just mentioned, there should be a head tag that includes the metadata. You can specify the document title, you can specify the styles of that document, you can run some JavaScript there. And here we close the head tag and then starts the body of this document. So all the content you see on a web page, they are in the document body. So that is an HTML document. And then, so I think most of you should be familiar with LaTeX. So basically, a LaTeX document consists of also some metadata, or what we call the preamble of a LaTeX document. So the preamble comes before begin document. So after begin document, you write the body of your document. That is a minimal LaTeX document. So now you know a document consists of two basic components. One is the metadata or preamble, and the other is the body. So for Markdown documents, it also has these two components. So for Markdown, you can specify metadata of the Markdown document in the YAML header. So the 3 dashes here means we want to include some metadata in the Markdown document. So we can specify things like the title, author, date, and many other things. And then after the second 3 dashes, you can start writing your document body using the Markdown syntax. So how do we convert Markdown to an HTML or LaTeX document? Usually, as I mentioned, usually we do that through Pandoc. But today I'm going to introduce another package, which is actually quite an old package named Markdown. This Markdown package is different with R Markdown. So the R Markdown package is usually what we call R Markdown nowadays. R Markdown is much more powerful and flexible and also widely known. If you're using R Markdown, most likely that you're using the R Markdown package instead of Markdown. So I want to briefly introduce a little bit history about the Markdown package. Actually, this package was written almost 10 years ago. So you can find it on GitHub from github.com/RStudio/Markdown. And it was later referred to as the first generation of R Markdown. And the second generation of R Markdown is actually the R Markdown package, as I just mentioned. The R Markdown package was born 2 years later. And since 2016, that is when the R Markdown package became mature. We have almost retired the Markdown package at that time. And because it's not that powerful and it's quite limited. Originally, the Markdown package was based on a C library called Sundown. And 2 months ago, I just deleted all the C code in the Markdown package and switched to another R package named CommonMark. So CommonMark doesn't use Pandoc. It uses some C code under the hood. So basically, I revived this Markdown package 2 months ago. And as I just mentioned, the development of this package has almost stopped since 2014. But I can't just let this package die on CRAN because many other packages still use it. So basically 2 months ago, I got some CRAN emails regarding some maintenance problems. And to be honest, I don't know much about C. So, but as the maintainer of the Markdown package, I have to fix any C problems found by CRAN maintainers. So I've been doing this for a few times until I was I felt I couldn't do this anymore because I don't know C code. So basically, I just decided, okay, let me just get rid of this C library completely and switch to the CommonMark package, so which is written by a great hacker, Jeroen Ooms. So the good news is that now I don't have to maintain any C code to convert Markdown to other document formats. So now I can just rely on CommonMark. So CommonMark can let you convert Markdown to several other formats, including HTML and LaTeX. So if you want to try the examples later, you have to install the development version of Markdown because there are many features that are still under active development. Honestly, there are even some features that I just implemented 20 minutes ago, just right before this talk. And sometimes I refer to this type of talk, this type of development, the talk-driven development. So whenever I have to give a talk, then I have to do some hard work in the development of packages. So if you want to try Markdown, you can install the development version there. So there's the main function in the Markdown package is named mark. So you can call Markdown : mark to convert some text, some Markdown text to another format. So here are two simple examples. So we can call Markdown : mark on the text hello world. So if you're familiar with the Markdown syntax, you know the 2 stars here means the bold text. So here we convert hello world to LaTeX, and then we got the output hello \text bf world. Text bf means bold font in LaTeX. So that's how we translate the Markdown syntax to LaTeX. And similarly, we can convert the text here to HTML. So for HTML, the bold text is represented by the HTML tag strong. And also this text is treated as a paragraph. That is what the P tag stands for. P stands for paragraph. So we convert text to a paragraph, which contains the bold text here. So with the mark function, we can generate the document body. How about the metadata? Without the metadata, we can't get a full document. So to generate the full document, we have to generate both the body of the document and the metadata of the document. So we will need a template to generate a full document. So here's a simple HTML template. So as I introduced in the very beginning, an HTML document looks like this. So it has several tags. So in this template, I have some variables. So like the title, CSS, bodies, all these variables will be prepared from outside. So I will show you an example later. So basically, this is how a template looks like. Or I can show you also a LaTeX template. It also has some variables like document class, title, author, date, body. So to go from Markdown to a full HTML or LaTeX document, So the first step is that we read the YAML metadata in Markdown and store them in a list of variables. And the second step is that we convert the Markdown body to the target format and store the body in the body variable. And the last step is that we read the template and substitute the variable names with their values in the above steps. So this is like a very simple R function that implements the idea on the previous page. So the toHTML function has 3 arguments: text, which is Markdown text input. Second argument is meta, which is a list of metadata. You can think about title, author, date, and other things. And the third argument is template, which is the template that I just showed you, like the HTML template or LaTeX template. So with this function in 3 arguments, we can convert the text to a full document. The first step is that we can convert the Markdown text to the target format using the comment mark colon Markdown HTML function. So this generates the body of that document, and we store the body in the body variable in meta. And then we will use the template. So we initialize the output to be the template text for now. And then the important step in this function is this for loop here. So basically we're looping through all the variable names in the meta list. We loop through all the names. And for each name, for each variable in the metadata, like we look for variables enclosed in a pair of $signs. We find this variable enclosed in $signs, and we substitute the variable with the value of that variable. So meta brackets with indexed by the name of the meta variable. So this is the value of that variable. We substitute the variable with its value in the output text. So that's what the gsub function does. So after all the variables in the meta list are substituted with their values, we will get the final output. So this is basically how Markdown works when you convert it to other formats. So we can run the function to HTML now. So for example, suppose we have a Markdown document that has the body hello world with world in the bold text. And then we pass some meta variables to the document, for example, title, try it. So then we use a template, which looks like this. It's an HTML template, which has the title tag and the body tag. So to save space, I didn't include the full template here, but just to show you the basic idea here. So I'm using a template with 2 tags. So after we convert the Markdown text to an HTML document, we get the output here. So you can see in the title tag, the title variable has been substituted with its value, try it. And similarly, in the body tag, we get a paragraph with the text, hello world. So that is basically how the Markdown conversion works under the hood. So now we can take a look at a real Markdown document, which has the YAML metadata and the body. So if you convert this document to HTML, you will get a full document, which looks like the output down here. So hopefully I have explained the basic idea clearly. And now let's go to some demos. So to use the Markdown package in RStudio, and I will use RStudio to demo the examples. So to use the Markdown package, you can specify the output field in the YAML metadata, and you would need to use the output formats Markdown : HTML format or Markdown : LaTeX format. So if you want to generate HTML output, you use the HTML format. If you want to generate a LaTeX or PDF output, you use a LaTeX format. And for both formats, you can specify several options, the Markdown options or the meta variables. So I will start demos now. Okay, so here's the minimal R Markdown example. And as I just mentioned, you can use two types of output formats, Markdown : HTML format or Markdown : LaTeX format. I think most of you should be familiar with Markdown documents. I'm not going to show you the full document. It basically consists of a few sections and different elements like the quotes, paragraphs, code chunks, which can generate plots or numeric output. You can use inline R code, and you can write math expressions and lists, and other things. So basically, if you specify the output format to be Markdown : HTML underscore format, you can knit this document just like you do with any other Markdown documents. You can click this button and knit this to an HTML page. So I think there's nothing surprising or new here. You should be very familiar with this experience. Click that knit button and you get an HTML page. The nice thing about the Markdown package is that it's very lightweight. So, it doesn't depend on any external tools like Pandoc, because it uses the Common Mark package, and Common Mark package doesn't use Pandoc either. So basically, it's using C code under the hood to do the conversion. And since it's very lightweight, the file size generated by the Markdown package is quite small. So for example, the HTML output here is only 4 kilobytes. If you use the other R Markdown documents through the R Markdown package, the HTML file is usually like 600 or 700 kilobytes. It's much bigger than the HTML files generated by the Markdown package. It's quite lightweight, and similarly, let's try the LaTeX format. Again, you can click the knit button to convert this document to PDF through LaTeX. So it's still the same content, but different format. You can still see all the sections and also the graphics. The styles are very minimal, and that's intentional. As I mentioned, the Markdown package it has a very minimal style. And you can specify any options or meta variables for these output formats. If you want to know which options are available, you can check out the help page. The help page of the mark function in Markdown. So if you want to see which options are available, you can go to the help for the options argument, which will tell you which will tell you a list of all possible options that you can specify here. Whether you want to embed images using base64 encoding, or whether you want to enable LaTeX math, whether you want to use MathJax, and or do you want a table of contents, and several other options. So I can quickly demo some of these features. For example, by default, it doesn't generate the table of contents, TOC. So I can change TOC to true, and then animate this document again. So you can see now we've got a table of contents generated in the beginning of the document. And similarly, you can decide whether you want to embed images in your HTML file or not. So here I'm using false, which means the images are not embedded. You can see there's the src attribute of the image tag is still a path. If I want to embed the images, I can change this to true. Then I click the knit button again. The images will be embedded. Now we inspect this element, you will see the src attribute is no longer a path, but the base 64 data. So what this means is that your images are embedded in your HTML document, so that your HTML document will be self-contained. But that means the file size of that HTML document will be bigger, since all of your images are included right inside this file. So that is a way to make your HTML page self-contained. Okay. So these are two quick examples of the different output formats. So next, I want to show you an application that I personally find interesting. So basically, you can turn an HTML page into a presentation with some simple CSS code. So here I showed the most critical CSS code to convert an HTML page into HTML slides. So basically, there's a CSS technique named CSS scroll snap. So if you want to learn more about this, I have a link here. Oh, actually, I will also share the link to my slides at the end of this talk. So with the technique of CSS scroll snap, you can actually turn a continuous HTML page into something that looks like slides. So basically, if you have several sections on the page and you scroll through this page, if you look closely, you will notice that if I scroll down, just by I'm pressing the down arrow on my keyboard, you can also use your mouse. You can scroll using your mouse, or you can press page down. So there are several ways to navigate through the page. So I'm using the up and down arrows on my keyboard. You can notice that if I press the down arrow only once, this page will be automatically navigated to the second section. If I press the down arrow one more time, it will jump directly to the third section. So the CSS code is quite simple, as I showed here. So basically, you have to specify an attribute on the container. So for example, here I'm using the whole HTML document as the container for the slides, and then you specify two other attributes on each slide. So the first attribute is that I want the minimal height of each slide to be 100 VH. VH stands for the height of the viewport. So basically the height of the window here. 100 means I want the full height of this window. I want each slide to occupy the full height of the window. That is what mean height equals 100 VH means. The second attribute is scroll snap align, which takes the value start. So basically that means if I scroll down, the next section, the start of the next section should be aligned to the top of your browser. So with these three attributes, scroll snap type, min height, and scroll snap align, you can turn an HTML page into a presentation. Actually, today the slides I'm using here is exactly based on these three attributes. So what you see here is actually a web page. You can see here's the URL, which is a local URL in my browser. It's a web page, but it has a few slides, right? I'm pressing up and down arrows on my keyboard. You can see as if there are several pages. So this CSS code is how this the HTML slides I'm showing here are implemented. So to show you that this is truly a continuous HTML page originally, I can press a key on my keyboard. So I'm pressing O on my keyboard. You can see this is actually just a normal web page. Zoom in a little bit so you can see more clearly. So this is just a normal web page. It's nothing special, right? A continuous page. But if you apply the CSS code here, you can turn this thing into something that looks very much like slides. Right? So that is the CSS technique. Oh, I forgot to demo the CSS. Yeah. Oh, okay. I will show that in a minute. So actually, I forgot to demo the CSS meta variable here. So I will show you right now. So basically, for the HTML format, you can specify the CSS meta variable to be either your local CSS file or the built-in CSS style sheets in the Markdown package. So I'm using the built-in CSS style sheets. I'm using the default style sheet and also the style sheet for slides. So that is what CSS default and slides means. So additionally, I need to use some JavaScript to convert my page into several sections. So that is what I'm using here, JS slides. That means I will use some JavaScript. So with these two lines of settings, you can convert the same document into slides. So now I'm going to knit this document again. You will see it will become a little bit different. My browser is too small here. I will show it in my web browser. So basically the same minimal R Markdown example. Now it has become slides. So what's useful for this presentation format is that if one slide takes more space than the window height, you can still scroll continuously. So now you can see this page, because this slide is the height is too large. So you can still scroll continuously on this page, and you can show the details of the certain elements to your audience slowly. And then whenever it hits the top of the next slide, your browser will immediately jump to the next slide. So you can see sometimes it's continuous when the slide is too tall. Sometimes it's like it can jump directly to the next slide. For example, this slide is also too tall, so you can scroll continuously. So that is the minimal example converted to slides. So basically with these two settings, CSS and Java and JS. Let's go back to slides. So to make it to make the presentation even more convenient, you can apply some JavaScript code to the page. So personally, I find JavaScript a lot of fun. You can manipulate anything on a web page using JavaScript, including your bank account balance. No kidding. Like you can modify anything. So as long as it's on a web page, you can right-click that thing and inspect it. So if you click inspect, and then you can see the source code of everything. Like so for example, imagine this is our bank balance. So you can modify things in your web browser. You can just double click on this and modify the text here. So if you want to become a millionaire, you can definitely edit anything here. Like, okay. It's quite flexible. So you can also do this through JavaScript. So previously, I was just editing the HTML text in the source pane directly, but you can also use JavaScript. So you can select things. It's very flexible. I can quickly show you some demos. You can select elements on a page or select several elements, for example. So since each slide has a class named slide, I can use document.query selector all with the class name. So that is one way to select all the slides. So now you can see there's an array which has 20 elements, which means I have 20 slides on this page. So I can query all of them. I can manipulate like one of them or all of them. Is up to you. It's like sometimes the browser has some convenient features. Like if you don't want to use the functions like query selector all, you can use a shortcut. If you click on a certain element in the source panel, the browser will let you use a shortcut named $0. $0 is basically the element that you selected in the source pane. So you can, so basically $0 means the slide here. So you can change anything. You can say $0.first element child, which means the first child of this slide, which is the title here. So first element child, you can modify its attribute easily. Oh, sorry. Selecting the slide here, selecting the first child, and you can query the text of that element by using the attribute inner text, and you can modify the text here. You can assign a new value to that. For example, this is my new title. If you run the JavaScript code, then you can see the title of this slide is modified. So basically, as I said, anything you see on the web page can be modified. It can be modified directly in the source panel, or it can be modified by JavaScript. So JavaScript is really flexible in your web browser. Now I'm going to show you some keyboard shortcuts that I implemented for the slides here. So to implement a keyboard shortcut, you can use a JavaScript event named key up or key down or key press. It's up to you. So you can add an event listener to your document. Document.add event listener. I want to listen on the key up event. Key up basically means when you press a key and then you release the key, the event will be triggered as soon as you release the key. So when you release the key, you get an event. So for that event, you can retrieve which key was pressed. by using e.key. So that key attribute is the key that you just pressed. So the code here basically means if the key that I pressed was F, then I will make this document full screen. So I'm using a method named request full screen here on the document element. If I press F, then the slides will go full screen. So, or if it's full screen, then you can press ESC to exit full screen. So now I'm pressing F again. So I press F, then this document will be in the full screen mode. And second keyboard shortcut is O. So if I press O, if the key is O, then I will add, I will toggle a class on the document body. The class is named Overview. So what that means is that if I keep pressing the key O, you will see something different. So now, look closely. Now I'm pressing O on my keyboard. You see the body has a new class named Overview. If I press O again, you can see the Overview class is removed. So this basically means this is what this is what toggle here means. If I press O, then the Overview class will be added to body. If I press O again, then the Overview class will be removed. What this means is that I can use CSS to style the document differently when the document body has the Overview class. So basically, if I press O, it will go back to the original continuous HTML page. So that means the overview. You can get an overview of your slides using just a normal HTML page. If you press O again, then it will become slides like this. So that is the keyboard O, keyboard shortcut O, and M is mainly for fun. So if you press M, it will toggle the class named mirrored on the document body. So now I'm going to press M, press M, then all the elements on the page will be mirrored upside down and right to left. So this is actually a feature in the Sharingan package, and the implementation is also very simple. It's one line of CSS code. Basically, when the document body has the class mirrored, I will show you the source code. If it has the class mirrored, you can see the definition of the mirrored style is transform scale -1 and 1. So basically that means I want to flip the page horizontally and also all the elements upside down. So with this one line of CSS code, you can mirror your slides. And one application of this mirrored mode is that sometimes you may give, for example, for an instructor, if you give your students some problems to solve, and you also have the solutions in your slides, and you can show them the problem and also show them the solution, but mirror the solutions, then they will not be able to read it. At least I'm not able to read the text after it's mirrored. It looks like Greek to me. I have no idea what the text is when it's mirrored. So if I press M again, then the mirrored class is removed, and then the document just becomes normal. Okay, so I think that's all I have for you today. If you want to view my slides, they're available at slides.yihui.org. Actually, let me send that to the chat box. Where is the chat box? Later. Yeah, if you have any questions, you can try Stack Overflow or RStudio community. If you have any Markdown issues, you can file them to the Markdown repo on GitHub. If you want to ask me any questions, you can use my GitHub discussion board. And I think I have everything on my personal website. That's it. Thank you.
Thank you, Yihui. Do we have any questions from the audience? Yihui, I actually have one question. So you showed a lot of how to transfer between different format. I noticed that in all your example, you don't have, let's say, video or image. Would that be a problem, or do we need special treatment on those things?
No. So for video, actually for if you only mean the HTML output, no problem. Web pages, you can embed any images or videos on web pages. But for LaTeX output, certainly you cannot embed like YouTube videos. You can find the code for embedding the videos on many websites, like on YouTube. You should be able to find the HTML code. You can just copy that HTML code and paste that into Markdown. It should just work.
Okay, thank you. Yeah, we have some comments from the chat actually.
Yeah, Ding Tang asked, could you briefly discuss the relation between Quarto and R Markdown? And when we teach R Markdown, should we switch? It depends. It's like we don't really have a suggestion. If you have been using R Markdown for like many years and you're familiar with it and you're okay with it, then it's totally fine to stay with R Markdown. Quarto, actually, I have a blog post on this topic. So, yeah, Quarto is quite new, but R Markdown is certainly not dead. So I have a blog post last year with Quarto coming. Is R Markdown going away? No. So Quarto was invented mainly for I'm not sure if I should say mainly for Python users. Like originally for R Markdown we have a big problem, which is R Markdown does support Python quite well, I should say. But for a Python user, it often feels weird that you have to use R, you have to install R to call Python. That just it doesn't feel right. So Quarto solves that problem by using Jupyter to run Python code, and also use Knitr to run R code. But the truth is that you can use Python code in Markdown, and you can use R code in Jupyter. Like both systems support multiple languages. It's just sometimes it's just awkward that for R users to install Python to run R, or for Python users to install R to run Python. That just feels weird. So for Python users, they are probably more familiar with Jupyter. So Quarto allows them to use Jupyter to run Python code. And also, Quarto has included most of the R Markdown features in one software package, which is Quarto. So you don't have to so previously in R Markdown, you have to use different packages for different tasks. Like if you want to create a website, you use Markdown. If you want to write a book, you use the Bookdown package. If you want to create presentations, you use Sharingan or other packages. So now with Quarto, everything is in one place. I think that's very convenient. But if I'm teaching students, I would slightly prefer teaching them Quarto directly. So Gina,
we have another question.
Now that you revived Markdown, how would you relate it to R Markdown for the users? Yeah, that's a tricky question. I think I will make it super clear that the Markdown package is probably not most people want, since it's very minimal and it's minimal deliberately. Like I don't want to develop any rich new features in the Markdown package. So basically, I'm looking for some features that are both simple and interesting and useful. So, for example, the things like cross references of figures or tables, or like bibliography or things like that. These are, I don't think they will be ever supported in the Markdown package. So.
Any other question? You can either put in the QA or this chat, and we are monitoring both.
So are there resources for creating our own templates, like the ones that you showed? That's a very good question. Share my screen again. For templates, yes. You can certainly start with default templates in the Markdown package, and the one thing I didn't mention here is actually the template. You can use the template argument here, like your own template HTML. So as long as you know how the template works, you can definitely provide your own template. Joyce said R Markdown was one of my big selling points for R, so I welcome Quarto with mixed feelings. Exactly, I have exactly the feelings. Okay. How the templates work. How the templates work. Let's see. I'm not sure if I'll be able to answer this one, but let's try. So first of all, the templates in the Markdown packages. The Markdown package is under the inst directory. Actually, the resources directory under the inst directory. So markdown.html and markdown.latex. So these are the built-in templates. So it looks like this. So if you want to modify anything, you can take this template and add or delete anything in template and pass that file to the markdown::mark function. So how that works, it's a little bit complicated. But the good news is that I think the R code, the R source code of this package is relatively simple. Maybe I'm wrong, but let's see where is the part for the template. It's here. It's basically the for loop that I mentioned in my talk. So for each variable in the meta variables, substitute the variable names with the values. So, one thing I forgot to mention is that the meta variables are not limited to the ones that are documented on the help page. So for meta variable, you can use any name. So all these names. So if you have an extra meta variable, then you will be able to use its value in the template using the syntax dollar followed by the variable name, then followed by another dollar. So this is totally flexible. You can use any meta variables for your template.
Any other question? If not, let's thanks Yihui again for this great talk and also this QA session.
Thanks. Yeah, if you have any additional questions, you always have the chance to ask me on GitHub. Thank you.
Thank you.